So next topic is in the chapter 4. We are in chapter 4, aqueous solution. So in electrolyte and non-electrolyte. So what are the electrolytes and non-electrolyte? It's, if you start from the it's you can say, think about that, it is look like something about the electricity. So electrolyte are the solute that exist as an ion in solution, and soluble ionic compounds are electrolyte, and its solution do conduct electricity. So the definition of electrolyte is a substance that dissociate into ions when dissolved in water. So for an example, we have seen in previous slide, then when sodium chloride dissolved in water, it forms sodium ion, it dissociate into sodium ion and chloride ion. So sodium chloride is dissociate into ions when dissolved in water. So sodium chloride is called electrolyte as well, because this is a substance which dissolve in water and conduct and produce ions. Any other example which produces ions that can be considered as an electrolyte. A non-electrolyte may dissolve in water, but it does not dissociate into ions when it does so. So many molecular substances are non-electrolyte and their solution do not conduct electricity. So when sodium chloride dissolved in water, it dissociates into ion and it's called electrolyte, and this solution can conduct electricity, but the non-electrolyte solution do not conduct electricity. For an example, glucose solid when dissolved in water, it do not dissociate into ions. So glucose solution is do not conduct electricity, and that is why it is an example of non-electrolyte. We will see some more example. So in this there are three figures. Picture shows, in one it says the two electrodes are dipping in a pure water. You can consider this an RO water, which is without any salt. So pure water also did not conduct electricity unless we add some electrolyte. A non-electrolyte solution does not conduct electricity also. If you are adding sugar or glucose in the solution, it will not light the bulb. And in the third example, it shows an electrolyte solution conduct electricity when we add sodium chloride salt in the water, and it produces sodium chloride, sodium ion and chloride ion. That solution can produce ion and can conduct electricity. So that is why it's called electrolyte. Now electrolytes are three types: the strong electrolyte, weak electrolyte and non-electrolyte. A strong electrolyte dissociate completely when dissolved in water. A weak electrolyte only dissociate partially when dissolved in water, and a non-electrolyte do not dissociate in water. So this is the difference between the strong electrolyte and weak electrolyte. So we'll see some more example about the strong electrolyte and weak electrolyte. So a strong electrolyte definition says dissociate completely when dissolved in water, and its equation for the reaction of its dissociation looks familiar. For an example, sodium chloride when dissociated in water, it produces H plus ion and chloride ion. It is very HCl is a very strong acid, and acid dissolved in water, it produces very quickly hydrogen ion and chloride ion. So that is why it's called a strong electrolyte. A weak electrolyte only dissociate partially when dissolved in water. Its equation indicate a chemical equilibrium where a reaction goes both forward and backward. So you may have seen this the sign. Mostly we write for the reaction which move forward from left to right. Left side is reactant, right side product. So a reactant is converting all the way into product. We write this one side arrow. And in case of weak electrolyte, for example acetic acid, or you can say vinegar, when dissolved in water, it partially dissociate into hydrogen ion and acetate ion, and some acetate ion and some hydrogen ion combine and they make again acetic acid. That is why it's called weak electrolyte. And these ions and this aqueous acid exist in equilibrium. Equilibrium means they have some percentage of ions and acid in the solution. Thus 100% acid do not dissociate into ions. So that type of solute or substance is called a weak electrolyte. So we'll see some example summary of electrolyte behavior in common soluble ionic and molecular compound. So a strong electrolyte, if all the ionic compounds are a strong electrolyte, and if ionic compound weak electrolyte, so none of the ionic compound is weak electrolyte. This table shows that all the ionic compounds consider as a strong electrolyte. So ionic compound cannot be weak electrolyte and cannot be non-electrolyte. Molecular compound are strong acid. They can, so if the strong acid is there in the water, it will consider as a strong electrolyte. Weak acid and weak base is considered as a weak electrolyte, and all other compounds are considered as a non-electrolyte. So molecular compound can be a strong electrolyte, can be weak electrolyte, and can be non-electrolyte. But ionic compound are always a strong electrolyte. They cannot be weak electrolyte, they cannot be non-electrolyte. So this was example of the electrolyte, and then we'll see the other topic in the next video.